Scoping is essential to any programming language as it determines how and where each variable is accessible in your code. We've all had moments of doubt while coding, contemplating our code, guessing whether or not we can access this variable here, would modifying it affect this variable and thus part of the code that used it elsewhere? Or some of you might have encountered this weird behavior where we have a fully functioning code, but if we add this assignment after the print, get ready for it, an error is thrown. So to stop second guessing and fully understand our code, let's dive into this core Python topic, scoping. Let's start by defining what a scope is. A scope is a region of your code that has its own namespace, its own list of variables that are local to it and accessible from it. So, how are these regions defined? In other programming languages, such as in C++, block scoping is utilized. This means that any block of code enclosed by curly brackets defines a new scope. For instance, if a variable x is defined within an if condition, like so, trying to access this variable outside these brackets will result in an error clearly stating that x was not declared in this scope. This is clearly not the case in Python, as Python has no such usage of curly brackets and it uses indentation instead to separate parts of code. So are indentations responsible for creating scopes in Python? Well, not exactly. If we try to run the same code in Python, defining this x variable inside an if statement, running this code doesn't throw an error at all and works just fine. As it turns out, Python uses function scoping. This means that defining a function is the primary way Python creates a new scope in our code. So here we'll define a function f and create a variable x within it. Printing x outside this function throws a name error stating that name x is not defined. That's because this function creates its own scope, meaning that any variable created inside of it will only be accessible inside of it. So printing x inside the function works just fine. Even if we create a nested function g and print x inside of it, that's perfectly fine as we are still inside the scope of the function f. So we will go inside f's function, define this variable x inside its scope, then we'll define a function g that prints x and we'll call g to execute this print, which as we can see has access to the variable x. We can also notice that the function g is itself defined within the function f, making it only accessible within f's scope. So if we try to call the function g outside the function f, here you go, the same name error as before is thrown. Let's talk about this name error. When does Python actually throw this error? There should be some kind of rule, right? A rule that specifies how Python searches for a given variable name and only when it's not found to throw this name error. Well, it turns out Python follows the LEGB rule to do just that. Whenever Python has to search for a variable name, it always starts searching in the local scope. If the variable is found there, that's great. If not, it moves on to search for it in an enclosed scope. That is a scope that encloses the current scope, such as the scope of f here that encloses the scope of g. If the variable is still not found in an enclosed scope, the search is moved to the global scope. This is the topmost scope in a Python program. Any variable defined outside of any function is actually a variable defined in the global scope. That's why we call such variables global variables. Finally, if the variable is yet to be found in these three levels, the final search is conducted in the built-in scope. This scope contains names such as keywords, functions, exceptions, and other attributes that are built into Python. We can actually print all built-in names by importing the built-ins module and printing dir on it. And now, if after all these searches Python hasn't been able to find the variable name we're searching for, this is when a name error is thrown. Alright, let's play a game to solidify this understanding. Your goal is to correctly guess whether a name error will occur in the following examples. Let's start with an easy one, where x is defined in the global scope, and within the function f, we're attempting to print a variable named x. What's your guess here? Anytime a variable is referenced, Python will follow the LEGB rule I just mentioned. So we'll start at a local level, and we can see that there are no definitions of a variable called x within this function's scope. As f is not a nested function, there is no enclosed scope to search in, so the search directly resumes in the global scope. Here, a variable x is in fact defined, so we successfully found this name and the print function will execute without any issues. That's great. Let's move on to the second example. Here, we're just printing a variable named min inside a function f. What's your guess for this one? Well, let's once again follow the LEGB rule. Searching in the local scope, there are no variables named min defined here. We directly resume searching in the global scope where, once again, we don't find any definition of a variable named min. This is where many of you might have guessed that a name error will be thrown, but don't forget that there's still one scope level we need to search before doing that, and that's the built-in scope. Searching this scope, sure enough, we find a variable named min. This is the built-in minimum function that returns the smallest element in a given iterable. So the code will not throw an error and the variable min is printed out successfully. Finally, let's take a look at this example. Make sure to pause and guess before resuming the video. Here we have a function f within which a function g is defined. Inside the function g, a variable x is set equal to 10. Then g is called. Finally, we're printing x here. So this is where we are trying to access a variable named x. So the search will start within the local scope of f. Within this scope, there are no definitions of a variable named x. As f is not nested, we move directly to the global scope, where we also don't find this variable, and finally search in the built-in scope, which also leads to no results. This is why in this scenario a name error is thrown as Python wasn't able to find this variable x. In this example, x is actually defined in a scope nested within f and we have no access to that here. It's like defining a variable inside f and trying to print it in the global scope. When searching for variable names, remember that we always go up in scope levels, never down. Now that you've earned your LEGB badge, we're ready to move to a very important topic. You are well aware that you can assign the same name to a variable in two different functions, and this will not mean at all that these are related whatsoever, right? Well, now you understand that this is because of scoping. Each of these variables are defined within their respective scopes that don't interfere at all with each other. That's great, but what about defining variables with the same name in a scenario where scopes overlap? For instance, say we set a variable x equal to 5 in the global scope. Then within a function f, set x equal to 10 and print x. Calling the function f will print out 10, which makes sense because we just set x equal to 10 before the print, right? What if we also print x after calling f? What would you guess the output to be? Turns out this second print will output the value 5. Does this mean modifications to global variables within functions don't affect the global variables? Well, not really, as that's not what's happening here. Whenever you initialize a variable, like so, Python adds this variable to the current scope. It doesn't search at all for the variable name, it simply creates it. The searching of a variable name happens when we need the value of said variable, such as when printing x or even when setting a new variable equal to x plus 10, for example. In these scenarios, Python will have to look up this name and use its corresponding value. So going back to this example, what do I mean by Python adding this variable to the current scope? What happens with the x defined in the global scope? Well, these two x's are completely different, and this is for the same reasons the two x's defined in two different functions are also completely independent. Sure, these two variables share the same name, but each of them is defined in a different scope. This x is defined in the global scope, whereas this X is defined within F's scope. So here when we print X, and once again, following the LEGB rule, Python will directly find X in the local scope and stop its search. It already found X, and will use this local X in the print. Whereas here, when searching for X, there are no local or enclosed scopes, so the search is directly conducted in the global scope. And sure enough, X is defined in the global scope, and it is this X that is utilized in the print. So within a function, if a variable with the same name as a global variable is defined, this doesn't really matter, as these two will be completely independent from one another, each residing in different scopes. But what if you actually wanted to modify a global variable within a function? Can you do that? Well, of course you can, but you'll have to explicitly say that in your code. And this is done using the global keyword. Writing down global x before setting x's value to 5 effectively tells Python to search for a variable named x in the global scope. If it is not found, then create a global variable named x. If it is found, such as in this example, then whenever x is used in the rest of the scope, make sure to refer to that global x, rather than creating or modifying a local variable named x. So running this code, we can see that both prints output the value 10, confirming that the modification within the function affected the global variable. That's awesome. Let's take a look at another example. Say we have nested functions f and g, and x is defined both in the global scope as well as in f. We already know the global keyword, which will allow us to access the global variable x and modify that. But what if we wanted instead to modify the x defined in f? So in other words, to modify the x defined in an enclosed scope. That's where the nonlocal keyword comes into play. By writing down nonlocal x before this assignment, whenever x is used in the function g, x will now refer to the variable defined here, not the global one. Let's verify that by printing x within g, printing x within f after calling g, and finally printing x after calling f in the global scope. And sure enough, we can see the value 20 printed out both within g and f, but the value 5 printed out in the global scope, as this has nothing to do with these modifications. One small note here is that the nonlocal keyword cannot create a variable name if it is not already created in an enclosed scope. But the global keyword is able to create a global variable, right? So why is this different? Well, imagine having multiple nested functions and none of them define a variable named x. Then you write nonlocal x in the innermost function. How would Python know where to create this variable x? It could be in f, g, or h. So for this reason, nonlocal can only be used to access already defined variables and doesn't support creating new ones. Before going over the example we've all been waiting for since the start of the video, let me give you some pieces of advice. Everything I've shown you in this video is purely for demonstration purposes and to understand at a fundamental level how things work in Python. But remember to always champion clean code whenever you think of implementing any solution. For instance, we saw how a variable defined inside an if condition can still be accessed outside that if condition. But in practice, I would almost always advise against this practice. What if the condition isn't met and you try to access this variable afterwards? What happens then? Well, an error occurs, which is something you never want in a production-ready code. Instead, it's better to define the variable outside the if condition, possibly with a default value or simply initializing it to none, and then modify its value based on certain conditions. Another thing worth mentioning is the usage of the global keyword. When you're first introduced to this keyword, it looks super cool and you'll want to try it out in all your codes, right? While I definitely encourage you to do just that to get the hang of it, be careful not to overuse it in your code. Modifying global variables inside functions is generally a bad practice, as it makes your code much harder to debug, as any line of code in your whole program could be responsible for modifying a given global variable. That's why it's preferred to have self-contained functions that don't modify anything outside of their own scope. This in turn will make debugging much simpler down the road. Then again, there are situations where the global keyword can be very elegantly utilized to write some clean code in a somewhat small and self-contained script. Okay, it's finally time to look at this super weird example. Here we have a global variable x set to 5. Then we're printing x inside a function f and calling f. Running this code all works fine as expected. But now, if we simply add x equal 10 under our print statement, which seems like a completely innocent line of code which is executed after the print, well, this now causes an unbound local error when trying to print x in the previous line. Turns out, Python scans the code of a function before executing it and considers any variable for which an assignment is made to be a local variable, unless we specifically use the global or non-local keywords. So here, x is already considered a local variable. So when we try to print x, Python searches for x, finds it in the local scope, but doesn't find any assigned value to it, which in turn causes this error to occur. And by the way, this error is a subclass of the NameError. This behavior is great as it prevents us from writing ambiguous and dirty code, where in one part of the scope we're referring to a global x and in another to a local x. Python is basically telling us a variable name in a given scope should only mean one thing throughout the entire scope. Now, if you want to widen your scope and have access to much more Python knowledge, all you'll have to do is click on one of these videos. And as always, don't forget to like if you want to learn even more Python.